Martin plays tennis at night under floodlights. When he stands 4.5 metres from the base of a floodlight, he casts a shadow 1.4 metres long. If Martin is 1.7 metres tall, how high is the floodlight? First of all, let's recognise the important information of this question. We know it is 4.5 metres from the base. Martin stands. He casts a shadow 1.4 metres long. We know Martin is 1.7 metres tall. And the question's asking us how high is the floodlight. With this information in mind, we are able to draw a diagram. So we've got our floodlight here. We have our base here. We have our light streaming from the floodlight coming down to where Martin is standing. Let's draw Martin. The light continues and a shadow is cast. We can then put our known information in. So if Martin's here, that means 4.5 metres from the base of our floodlight. Martin's shadow is 1.4 metres long. We know the height of Martin is 1.7 metres. And from here to here, to our base, is our unknown, n. We can also say that here and here are our right angled triangles. We are then able to label our triangle. We can see that we've got one larger triangle and we've also got a smaller triangle here as well. So therefore we have a triangle A, B, C and a triangle D, B, E. We can also say that these triangles are similar. And three lines diagonally mean similar. And we can say that they are similar because they share a common angle, B, and they have two right angles. And our triangle theorem states that all angles of a triangle must equal to 180 degrees. So for example, say that angle B was 55 degrees. We've got 180 minus 90 for angle E, as it's a right angle, minus 55. That gives us 35 degrees. And that can both be for angle A or for angle D. With this now in mind, that they are similar triangles, we are able to find n. We are given 3 known lengths and a 4th unknown. So we are able to go BE, our bases, over CB, so our base of the little triangle and the base of the big triangle, over the height of the little triangle, which is DE, over the height of the big triangle. And we must keep them the same, so you can't go BE over CB equals AC over DE, as you put the little triangle first, so you must put the little triangle's height first as well. We can then substitute our values in. So BE equals 1.4, CB is from here to here, which means 4.5 plus 1.4 is 5.9. Our DE is the height of Martin, so we know that's 1.7. And our AC equals n. Now we begin to find n on its own. First of all, times both sides by n, and you get 1.4 over 5.9 times n equals 1.7. Times both sides by 5.9 to eliminate both of our denominators. And we get 1.4 times n equals 1.5 times 5.9. Multiplying that, 1.7 times 5.9 gives us 10.03. To then get n on its own, let's divide both sides by 1.4. And therefore equals 7.16, and its approximation value, so we do two squiggly lines. And because we were given our information in a 1 decimal place, we must give our final answer in a 1 decimal place. So it becomes 7.2 metres. Because we were given a question in a worded, because the question was worded, we must then give our answer as a worded answer. So we then say, therefore, the height of the floodlight is 7.2 metres. And you have successfully answered the question.